Every week, I take out my family's recycling. We've got glass and paper in one container, metals and plastic in another, cardboard on its own. I even collect the soft plastics that get recycled at the supermarket. But is there a point to doing any of this?
I mean, for one thing, we live in a world where the richest man on the planet took 355 flights last year, emitting 4,000 tons of CO2. Sort of puts washing out your yogurt pots in perspective.
But also, how much of this stuff, especially the plastics, actually gets recycled? And how much of a difference does this make to the environment and specifically to climate change? To answer that question, I chatted to experts and dived into the statistics on recycling, including here in the UK specifically, and found that this is a bigger deal than you think.
To show you what I mean, I built this digital recycling centre to show you what happens to our waste when it is thrown away and what exactly recycling does. According to UK government statistics, household waste is 22% paper and cardboard, 18% food waste, 14% plastics, 13% garden waste, 8% textiles, 5% glass, 3% metals, with the remaining 17% being various other materials. Here in the UK, this household waste is collected and brought to a material recovery facility, or MRF, where it's divided by material.
There's different ways to do that first level segregation. Some people would be really advanced and be using robots. There's usually a lot of conveyor belts involved. Sometimes we're even picking things out, especially when those are really problematic or valuable. And then those would then go to secondary facilities where you're really trying to recover value from that materials.
This is Professor Mike Shaver, Professor of Polymer Science and Head of the Sustainable Materials Innovation Hub at the University of Manchester. We'll be hearing a lot more from Mike in a little bit. For now, let's sort the flow of household waste coming into our digital centre by material and see how much of it gets recycled. Note, by the way, that we're not going to look at food waste or garden waste because organic waste like that is kind of its own thing that probably deserves its own video.
Our first level sorting picks out glass. Glass is widely recycled. Here in the UK, about 71% of container glass gets recycled, while in Belgium, it's 98%. And it's divided into different colours before being crushed and melted down to make new products.
This has two key effects. Firstly, by recycling existing glass, we limit the need to extract new raw materials to make new glass. So that means sand, soda ash, limestone, all that kind of thing, all finite resources. But secondly, we use less energy than in the production of new glass. Supply chains are shorter, less heavy stuff needs to be moved around.
According to research in Scandinavia, producing 1 kilo of recycled glass emits 41% less carbon dioxide than producing a kilo of new glass, with additional savings in water consumption and air pollution. Great! After the glass is filtered out, our plant now isolates metals. These are sorted further using magnets into ferrous and non-ferrous metals.
Metals in general are extremely energy intense to produce. You've got to get the ore out of the ground, extract what you want from the ore, melt it down, and then cast or forge or whatever to get your final metal product. All of those steps take a lot of energy. It just makes sense to reuse existing metals like copper and aluminium and steel and have to cast or forge those things, but not have to do all those other energy intense steps. So metals are really widely recycled.
In construction, it's estimated that 98% of steel gets recycled, while in household waste in the UK, 41% of all metals get recycled. And that has a big environmental impact. That Scandinavian research I mentioned previously estimated that producing 1 kilo of aluminium produced 11 kilos of carbon dioxide, while recycling 1 kilo of aluminium produced just 0.4 kilos of CO2. That's a 96% reduction. For steel, you see an 87% reduction. Elsewhere, I saw a 99% reduction in energy consumption for recycled tin.
It's for this reason that an astonishing 3/4 of all aluminium that's ever been produced is still being used. 70% of all steel that's ever been produced is still being used. When you save this much energy, recycling just makes economic sense.
So far then, that's 2 materials that have huge energy savings when you recycle them, so recycling is really important. Things get more complicated with our next filter, paper and cardboard. These are widely recycled and have been for some time. In Europe, about 80% of paper products are recycled.
And like glass and metals, recycled paper requires less energy to produce than fresh paper. Though, because the process of recycling paper is surprisingly energy intense, the savings aren't quite as dramatic. Sources online vary between like 40 and 70% reductions, depending on where you're doing it. And with regards to carbon emissions reductions, it's not very clear cut. It actually depends on how you're powering your recycled paper mills. If you're using fossil fueled electricity, then recycled paper can actually have a higher carbon footprint than fresh paper. And there are limits to how many times paper can be recycled. While glass and metals can, in theory, be recycled an infinite number of times because their properties that we find useful are basically elemental, paper is made of lots of little fibers, typically plant fibers like cellulose, that bond to each other, and they provide paper with lots of strength even when it's really thin. Sorry, that's probably awful audio. And when you recycle paper, you mulch it down and break apart those fibers, shortening them. And after 5 to 7 recycles, the fibers become too short to provide the necessary structural integrity and the material kind of becomes worthless. Though you can extend the lifespan by adding in fresh or virgin fibers, which is why you often see paper with 95% recycled content. But it still provides a hard limit on the effectiveness of paper recycling.
So that's 2.5 sustainable materials so far. As I mentioned earlier, there are still other materials in our waste, notably electronic waste, that we're not discussing in this video. That's not to say these materials aren't important. In particular, e-waste really deserves its own video. But to prevent this video from being several hours long, I had to draw the line of materials somewhere. And the last material on this side of the line is plastic.
If you know anything about recycling, you probably know that plastic recycling doesn't really work. Like, you may have watched Climate Town's video on this about how the plastic industry pushed for plastic recycling despite knowing that it wasn't really up to the task, and it was kind of just they were covering their asses.
If the public thinks the recycling is working, then they're not going to be as concerned about the environment.
Well, that's not good.
And the gross statistics certainly bear this out. A 2017 paper estimated that 8.3 billion tons of plastic had been produced up to 2015, with 6.3 billion tons of this no longer being used. 79% of that 6.3 billion tons of plastic waste was accumulating in landfills or in the natural environment. We've previously made a whole video about the environmental and health problems of this plastic pollution. 12% of all plastics ever made have been incinerated, and just 9% have ever been recycled. Less than 1% of all plastics ever made have been recycled more than once.
OECD data from 2019 indicates that globally, just 10% of all plastics are recycled, though that number varies depending on where you are. It's, for example, 12% in Europe and just 4% in the United States. And what may be most damning is this report from Plastics Europe, which indicates that in 2022, 32.3 million tons of plastic waste was produced in Europe. Of that, only 11.6 million tons was collected for recycling, and of that, only 8 million tons was actually recycled. And this is the best these figures have ever looked.
So the last part of our digital recycling centre is really leaky. Loads of stuff arrives for recycling that just doesn't get recycled or has its material reclaimed. Most often, it's incinerated in what's termed energy reclamation, producing significant carbon emissions and air pollution. And even then, many online resources point to the fact that many plastics that are recycled are actually downcycled, meaning that, for example, a PET Coke bottle won't be recycled into another Coke bottle, but instead put into plastic fibers for clothing that then won't be recycled and instead thrown away. And this isn't even getting into the whole debacle of resin identification codes on plastics being intentionally similar to the recycling symbol, making it look like things can be recycled that in fact can't.
And to be honest, this is what I expected coming into this video. Like, it's what activists have been saying for a long time. Metal and glass recycling, good. Plastic recycling, bad. In fact, plastic's bad. Like, we shouldn't be using plastics, we should be using recyclable, sustainable materials like metals. In fact, I spent months accumulating recycling in my studio to make this point about sustainable and unsustainable materials. But
there's no such thing as a sustainable material. There is only a sustainable system in which that material exists.
And this was the moment in my interview with Mike where my entire perception of this topic changed. In the rest of this video, we're going to come back to plastic recycling in much more detail and explain how it's actually better than you think, and how we can make recycling in general the most worthwhile. But first, let's just talk about this paradigm shift that just happened.
We are currently using the resources of our planet at an unsustainable rate, creating myriad environmental and health problems that we are all becoming painfully aware of.
But the problem is not as simple as using the wrong materials to make and maintain the modern world, though that is part of it. The problem is that we have built a system of using those materials that is clearly unsustainable. And maybe that's especially true about plastics, but not uniquely. At one end of the life cycle, paper only forms a sustainable system if the trees cut down to make new wood pulp to make new paper are replaced with new trees. At the other end of the life cycle, glass recycling is not a sustainable system if glass is recycled into materials that are not themselves recycled. For example, fiberglass. Fiberglass can be recycled, but it's an expensive process, and so it just often doesn't happen.
Also, while we've highlighted that some plastics collected for recycling are incinerated due to contamination, a loss in the system, this is also the case for all other materials. For example, any piece of paper or card saturated with grease cannot be recycled. It gets incinerated. But many losses in materials occur further upstream. People frequently don't recycle glass or aluminium because of how a product is designed or how or where it is used. And that can be a bigger problem than losses in the plastic stream.
I already mentioned that metals like aluminium are extremely energy intense to produce, and that has a carbon cost associated with it. It's estimated that producing 1 kilogram of fresh aluminium emits 11 kilograms of carbon dioxide to the atmosphere. Compare that to the 2.1 kilos of carbon emitted to the atmosphere when creating 1 kilo of fresh plastic. So losses of aluminium, which absolutely do occur and need to be replaced, have a much higher carbon cost than losses of plastic. It's for this reason that displacing plastic Coke bottles with aluminium cans or glass bottles isn't so straightforward.
If we think about getting the raw material, right? So both of those have a higher footprint in terms of initial production versus plastic product, which are so completely atom economical, or the majority of them are atom economical to make and lower energy in terms of this production. If we think about having to heat, an aluminum can up to be able to melt that can, it's a much higher temperature profile than it would be for our plastic material.
With an additional problem for this use case specifically being that aluminium drinks cans are actually lined with a thin film of plastic. It's there to stop the contents from eating away at the aluminium. When the cans are recycled, you just burn that plastic. You don't get to recover it.
In fact, what's become apparent in researching this video is that there is something of a gulf that's emerged between activists and academics on this issue. The former being more interested in materials and the latter more interested in systems and processes. I think there's a lot of reasons for this. I think a message about materials is easier to convey than a message about systems. I think there's a particular focus on plastics and especially plastic packaging because we as consumers interact with that all the time, and it's really obvious in our litter and our mismanaged waste. So there's a recency bias going on.
We have this laser focus on packaging as a plastics material, and then people get into their cars and they're sitting on a plastic fabric seat and a polyurethane plastic soft thing underneath it, and probably a polypropylene back, and their dashboard is certainly polypropylene. So we exist in this huge plastic universe, but we're only thinking really about the plastics in packaging as the bit to demonize.
But none of this is to say that reducing the environmental harm of plastics is not the largest challenge of our materials system. It's a huge problem, and one that's probably more complicated than you think. But in order to meaningfully address that problem, I think we first need to zoom out and take a 10,000-foot view of the system that plastic lives in. Our world operates on a system that can be described as take, make, waste. In other words, you extract materials from the planet, use those materials to make something, use that thing, and then dispose of it. Obviously, on a planet with finite resources, this ain't gonna last forever. You will run out of raw materials. So a more sustainable approach looks something like this. You're still extracting some materials from the planet, you're still producing some waste, but importantly, most of your waste goes back into the make step. You are not just throwing stuff away, you're reusing it, you're recycling. But
can a person just buy and consume whatever they want and live sustainably by just trying to recycle as best they can?
No.
This ain't enough on its own. What you need is...
The circular economy is the concept that people throw around, and that's this idea that we also need to move beyond recycling. I think the messaging of recycling has been pretty poor, that people have thought, well, this is perfect. All of this stuff gets reused and none of it goes to landfill and none of it ends up being waste somewhere else. And I think the recycling industry, in a way, has done well at telling that story, but ultimately it's not quite true.
So as well as repurposing our waste, we need to change how we design and make products, such that we remove our dependence on extracting new raw materials. And this isn't something that most of us will do as individuals. It's something that we must force companies to do through government policy and through activism. What does that look like? Well, for one thing, making sure that companies make products that will last and are not designed to be disposable. And that's partly ensuring construction quality, but it's also changing how a product is intended to be used. And Laura, who you just heard from, provides an excellent example of how this can be done, because she is responsible for the UK's ban on disposable vapes, coming into law next week.
It's about 8 million disposable vapes that are used every week in the UK. So the scale of this problem is massive. So if people want to vape, they can get a reusable, rechargeable device, but we definitely should not have single-use, disposable electronic devices that are also cheap and filled with chemicals that young people are getting a hold of. There was this kind of public health environmental collaboration.
And we know that this kind of policy intervention works in reducing the amount of waste we produced. To give you an example, in 2014, the UK alone got through 7.6 billion, with a B, single-use plastic bags in a single year. Then, in 2015, a 5 pence per bag charge was made mandatory by law, later increased to 10 pence. If you're not from the UK, 10 pence is a little over 1% of a pint of beer in London. The result of this was that in 2022, the UK got through 133 million single-use plastic bags. Don't get me wrong, that's still a lot, but that's a 98% drop. And other territories like California and New Jersey have seen similar reductions in plastic bags after similar charges were made mandatory. Policies affecting how products are designed can be highly effective at reducing waste when they are intelligently designed. But more importantly than just changing designs is just using less stuff.
The best thing to do is to buy a jumper and to have that be a really good quality jumper, and for you to take really good care of that jumper and keep that jumper and keep wearing that jumper forever. By doing that, we can keep things in their highest value condition longer and prevent the consumption of materials.
Or in other words, in the spirit of this video, I'm gonna recycle a joke from that Climate Town video I mentioned earlier.
We gotta stop treating recycle like it's the Beyonce in the Destiny's Child of reduce, reuse, recycle. Beyonce is reduce, reuse, and recycle is the other two.
Thanks, Rolly. In summary, recycling is a necessary but not sufficient condition to circularizing the economy. In its current form, recycling has a bunch of problems in terms of specific materials and more generally. But without it, all the other interventions we make further upstream in terms of how we design products and what we make them out of they aren't going to be as effective. In fact, without recycling, those upstream policy changes could actually produce more environmental harms. Recycling is necessary.
To return to our digital recycling centre, what is already being done is worthwhile. It's necessary to have a more sustainable economy, but it's not perfect. We need to improve the rates at which individual materials are recycled and reclaimed once they arrive in the centre. But at the same time, the biggest policy interventions, the ones that will make recycling the most impactful, occur upstream, in determining what kind of waste arrives in the centre.
By the way, sorry to interrupt, if you're interested in how we made this video, especially the 3D animation stuff, but also the writing and research, my editor and I have made a bonus video looking behind the scenes that's available right now to patrons. Patreon is the reason I can make these videos as my full-time job. If you like the stuff that I make and you'd like me to make more of it, then patreon.com/SimonOxFizz is the best way to support me.
In exchange for a couple of pounds a month, you get early access to videos, exclusive content every month, including a behind-the-scenes vlog, and at higher tiers can vote on topics for me to cover. Thank you so much to everyone who already supports me, with a special shout out to Rory Andrews, JP, and Unai Ansede.
Now, with this 10,000-foot perspective and that emphasis on systems, let's zoom back into the most controversial part of recycling: plastics. As we've already heard, the way society creates and uses plastic is producing enormous harms to the environment and to our health. But as we've also already heard, just replacing all plastics with alternative materials isn't the solution. I want to be clear, there are plenty of applications where we could and maybe should be using alternative materials to plastics. For example, disposable items like cutlery or straws. But
the environmental implications of most of our alternatives are actually higher than the plastics themselves. We have to really stop extracting, and to stop extracting those raw materials, we have to get much better at doing the recycling step. And the problem is not that the plastic is bad, the problem is that the plastic is not valued. And so we're not treating it with care.
But the problem is that stubbornly low figure of just 10% of plastic being recycled, and when stuff does arrive at the centre, often being rejected. Like, plastic recycling just doesn't work, right?
Well, no, actually. You have to remember that plastic refers to a hugely diverse range of materials and use cases, like soft plastics all the way to rigid plastics like PET and HDPE and PVC. And recycling rates vary dramatically depending on which type of plastic you're talking about. So while in the UK 37% of all plastics get recycled, 75% of PET bottles get recycled, 78% for HDPE bottles.
What's really easy to recycle is what, in a technical sense, are called pristine monomaterials. Plastic milk bottles. So here in the United Kingdom, those are made out of HDPE, and they're really only HDPE, and they're really consistent. And so I can take those milk bottles, clean those milk bottles, get those all back into milk bottles in a really consistent way. And we have a very high recycling rate on milk bottles. Same thing with PET drinks bottles. And so the bits that we're losing are because we don't have idealized recovery systems, not because there's a technical gap.
In other words, recycling certain types of plastic works. It is being done in the UK and it is effective. Like, it's worth you putting your rigid plastics in your recycling bin. That's not to say that the system is perfect. You've almost certainly heard stories of plastic recycling being shipped abroad from the UK or just, being burned.
All of our mechanical recycling infrastructure is at or over capacity. We don't have enough infrastructure to deal with the stuff that we would want to deal with.
So how do you fix plastic recycling? How do you get, here in the UK, from 37% to 90 or 100% recycling rates for different types of plastic? Well, let's work our way through the supply chain. First of all, down here, we need to recycle better.
That means investing more in mechanical and chemical recycling infrastructure, but also standardizing what recycling is collected by local authorities and how it is collected, something that is actually being rolled out in the UK at the moment.
Doing this should prevent what Mike refers to as cannibalistic economies, where, for example, a company might buy PET bottles from a recycling plant to make recycled plastic jumpers, which then cannot be recycled as easily as if, for example, another company had taken those PET bottles and recycled them into more PET bottles. So you need to maintain enough feedstock for the entire industry. But this is still expecting consumers to do the hard work, something that has been the big criticism of plastic producers when it comes to recycling. Rightly. The more effective interventions take place further upstream, starting with changing what kinds of plastics are being made. We've already talked about reducing the amount of plastic being produced, and I really cannot stress enough how vital that is, by, for example, designing products to be reusable. But something we haven't mentioned yet is what those plastics are made of. The UK has the plastic packaging tax, which requires manufacturers and importers to deal in plastic packaging that is at least 30% recycled plastics, or face a fine. And that's great, you're incentivizing the use of recycled plastics. But as we've already learned, gross plastic statistics obscure the differences between different types of plastic.
I would say it's too easy to go for 30% recycled content in a PET bottle. We can easily get to 70% if we had that feedstock, and actually that would provide an economic incentive to take things away from cannibalistic economies if we were to go and do that. And if we were to think about, let's say, food grade polypropylene, right? So this would be the plastic that's in your yogurt pot. We actually don't have any food grade recycled polypropylene. It's literally impossible to put 30% recycled content in it because the stuff doesn't exist at scale. And it's regressive to target 30% for PET bottles because we already have the technology to go way over that.
So we need more specific legislation for recycled material percentages in different types of plastic. But not just that. For the second time in his interview, Mike slightly blew my mind.
Plastics are not polymers. A plastic would have as its main component a polymer, but it's actually like a formulated product. In the same way as your shampoo contains all kinds of different things in there to be able to make it shiny so that you can squeeze it out so that it delivers on the function, we have created plastics which are formulated materials and have all kinds of stuff added into them to be able to deliver the function. The biggest policy recommendation I think that we could make is to say, well, we need to know a heck of a lot more about what those additives are so that we can then design better recycling systems downstream. Because we don't need 50 different antioxidants. We need an antioxidant because it performs a particular function, but we need a disclosure of that.
In other words, by standardizing these additives and ideally displaying them on whatever product they end up in, almost like an ingredients label on a foodstuff, we can more efficiently design recycling systems for these materials. And we as consumers can more efficiently engage with those systems. But in my opinion, the most important intervention, the thing that raises the importance of plastic recycling more than anything else, takes place here.
I've spoken at length on this channel about how we are currently subsidizing the fossil fuel industry, by one estimate to the tune of $13 million per minute. In effect, subsidizing gas, oil, and coal, paying to make the climate crisis worse. But that's not all.
That oil and gas industry produces lots of different molecules. And some of those molecules are waste molecules from the provision of energy. And so actually by subsidizing oil and gas, we have what we would call virgin plastic feedstocks, which are super cheap. They're very efficient to make because they're made out of the waste from the energy provision. And so we can kind of keep virgin plastics really, really low cost. And so what that means is that if we're looking at competing against two feedstocks, well, I could go and buy my virgin stuff, which is more consistent, is designed to do exactly what I want it to do, or I could buy recycled stuff.
We have a plastics crisis because we actively subsidize the creation of new plastic, devaluing plastic in general, and specifically making recycled plastic not cost competitive. In fact, you could argue that recycled plastic is only cost competitive when we, as consumers, price in the negative externalities of producing new plastic in the form of carbon emissions and pollution. If we remove those subsidies, not only do we stop financing our own ecological breakdown, we immediately increase the value of all the plastics already in the system. And it makes supporting recycling a no-brainer.
And these plastics should have immense value. We have created wonder materials that can, in many cases, be broken down and reused and recycled again and again. That should be valuable. And when we recognize that, of course, we're going to stop throwing them away and burning them. We will want to recycle them.
I started this video by asking, does recycling even do anything? And as I hope you now understand, the answer is definitely yes. Recycling is an essential, though not sufficient, part of circularizing our economy. It is effective at reducing energy use and carbon emissions, and even with the most problematic of materials, plastics, it is effective when done right. Recycling is worth doing.
If I can recycle, if I can get a clean stream and I can mechanically recycle that into a product that holds value, what I'm doing is I'm able to create a product that eliminates the extraction of virgin material from the planet. The challenge is to do that in the best way possible. It's not whether or not recycling is a good thing, it's that, is it sustainable, right, in the longer term? It's putting that into the system in which lots of different solution spaces are going to work. But it's not a panacea. It's not a silver bullet. It doesn't solve all of the problems, and it can't solve problems infinitely.
There are changes that we should make to how we recycle, notably making it accessible and simple. But most problems with waste management exist upstream, changing how products are designed, what they are made out of, and in disincentivizing the extraction of new raw material. And those problems can be addressed.
They are addressed through policy. Here are some specific policy recommendations that you can campaign for, notably removal of subsidies for the fossil fuel industry, but also standardization and greater transparency around additives to plastics, expansion of mechanical and, to a lesser extent, chemical recycling, and standardization and expansion of recycling. Like, there's good policy being laid down in the UK at the moment and in Europe, and you can take inspiration from this. Take it to your local representative in government and ask, would you support something similar?
Your local councillor, local councillors, your members of parliament, like, they can really champion these issues. I think reach out to your elected representatives. They are paid to represent us. That's their whole job. And I think it might surprise you. And don't be disheartened. Yours might let you down, but there's a whole bunch of others who are willing to take on your case for you.
And you, as an individual, at home and at work, can be part of this. Read up on what your local authority can and cannot recycle. If you're in the UK, use this website. It's linked in the description.
Look at those different options you have. Recycle well, try not to contaminate the streams, and buy things that will last.
As in so many things in life, my philosophy boils down to this. You have an individual responsibility to do your best within the confines of the system that already exists. But you also share a collective responsibility to improve those systems. Just because recycling is not perfect, that doesn't mean that it's not worth engaging with while we seek to improve the system. So, reuse less stuff, reuse what you already have, and recycle. It's worth doing.
Earlier this video, we met Laura Young, who, as well as being a PhD student and running a popular sustainability Instagram account, successfully lobbied the UK to ban single-use vapes.
This to me is a huge environmental win, and the story of how Laura made this happen is really interesting and inspiring, and it didn't quite fit into this video. So I made a whole other video letting Laura tell this story, and that's available to watch right now on Nebula.
I upload all of my videos early on Nebula and frequently upload videos that you can't watch anywhere else. Recent examples include my 2025 climate news summary to date, behind the scenes of my Tiny Earth video, and bonus interviews with expert guests.
But there's also a huge library of exclusive content from other creators. Notably, I'm really excited to watch 17 Pages by Bobby Broccoli. Like, this is like a new Star Wars film coming out for me. And you can watch all of these videos ad-free. That's because I'm part of the group of creators that collectively own Nebula, and we don't like ads. So we designed the service to run on a subscription model instead. You pay a subscription and it gets divided between the creators that you watch. And it also finances original content like Arctic to Africa, in which Downey Express documents catching the train from the northernmost passenger train station in the world going to Africa. I'm actually waiting to watch the next episode of this one. And you can get 40% off an annual subscription by going to go.nebula.tv/Simon Clark, which is linked down there in the description, but also available in the QR code on screen. That's go.nebula.tv/Simon Clark to watch my video with Laura about how the UK banned disposable vapes, and much, much more besides. Thank you so much for watching to the end, and a huge thank you must also go to Professor Shaver and to Laura for chatting to me. In particular, chatting to Professor Shaver was like a paradigm shifting experience for me personally, and I'm so grateful he gave up an hour of his time. There are links to Sustainable Futures at the University of Manchester and the One Bin to Rule Them All project, one of my favourite project names of all time, down there in the description, along with a link to Laura's Less Waste Laura Instagram. If you'd like to watch something else from me next, then here's 2 videos I prepared earlier. Let me know what you thought of this one in the comments. I'm sure there will be a lively discussion. And that just leaves me to say thank you so much again for watching. I'll see you in the next one.